For today, we're looking at probability with a die. You know, a die, it's a figure that's six sides, right? We throw them, we roll them, six sides. So here, for question number one, let's find the probability of rolling a divisor of 30. Divisor is basically the numbers I can divide into 30. Right? Or numbers I can divide 30 by. I know 1 goes into 30. I know 2 goes into 30, right? 2 times 15. I know 3 goes into 30 as well. I know 4 does not. But 5, 6. I know 7, 8, and 9 do not. But 10 does. As a matter of fact, then 15 and then 30. I was looking at all the divisors of 30, like all the numbers I can divide 30 by. Now my question is, find the probability of rolling a divisor of 30 from your die. Like, so you have your die. How many of these numbers appeared on the die? 5 of them. And the numbers are 1, 2, 3, 5, and 6. Then from this list, how many are on the die? 5 of them. So I'm going to put 5 on top. At the bottom is, how many numbers are there total in a die? How many numbers are there in one die? 6. So 5 out of 6. Remember, a probability, the top number is how many possible from the list. The bottom number is how many total in the die. So this one is 5 out of 6. Divisor or factored. Did you guys see factored question number 3? Divisor and factor is the same thing. So once again, divisor and factor is the same thing. Another key number is another key word is prime. Remember, prime is a number that can be divided by 1 in itself only, nothing else. So it says find the probability of rolling a prime number. Let me look at my list of my numbers on my die. 1, 2, 3, 4, 5, 6. Those are the possible numbers I can roll in a die. Remember, prime numbers are those numbers that can only be divided by 1 in itself, nothing else. Is 1 a prime number? Yes. Is 2 prime number? Because they can only be divided by 1 and 2 and nothing else. Is 3 a prime number? Yeah, only by 1 and 3 and nothing else. Is 4 a prime number? No. So I can divide it by 1, 4, and 2. Once there's a third divisor, no. Is 5 a prime number? Is 6 a prime number? No. Alright, so I have my prime numbers there. How many numbers I have on my list? 4. How many are there total on the die? 6. And I know before you guys were told simplify your fractions, leave it as 4 over 6. Like it's fine 4 over 6. Don't simplify fractions in probability. And let me move into the word multiple here. Find the probability of multiple of 1. Multiple sounds like multiplication. There's a multiplication tables of 1. So like 1 times 1, 1 times 2, 1 times 3, 1 times 4, 1 times 5, 1 times 6, on and on. How many numbers are there on my list? 6. How many numbers are there total on the die? So the probability I'm going to get a multiple of 1 is 6 out of 6. Like very likely. Alright. Any questions? 7. So find the probability of rolling a divisor of 8. Remember, a divisor of 8 is the numbers I can divide 8 by. I know 1 goes into 8, 2 goes into 8, 3 does not, 4 does, 5, 6, 7 do not, 8 does. I know if I roll a die I cannot get 8, so let me take 8 out, because I cannot get an 8. How many numbers are there on my list? 3. How many numbers are there total on the die? 6. Okay. Any other questions? Number 9. List all possible outcomes from rolling a die. So looking at question number 9, list all possible outcomes from rolling the. I have that one. Well, let me bring it up a little more. The numbers that if we roll a die, I can get a 1, I can get a 2, I can get a 3, I can get a 4, I can get a 5, and I can get a 6. Right? If I roll a die. Those are what come out. Like, what can you get? Does it list all the possible? There you go. Anything else? 7 or 10? Okay, looking at question number 10, it says find the probability of rolling greater than 3. So more than 3, I'm going to say from my numbers, I can get a 4, I can get a 5, or I can get a 6. Right, that's basically what I can get. If I roll a die greater than 3, 4, 5, or 6. So how many numbers are there on my list? 3. How many numbers are there total on the die? So 3 out of 6. We're good? Let me take all of the questions.